Hello guys, welcome back to my video. My name is Margareth Stevany Sinurat. I'm college student from Mathematics Education Study Program 2019 at State University of Medan. In this video, I will explain about Chapter 13 is Development of Modern Mathematics from Transitional Century to 21st Century. First, I will explain about the scientific revolution period. There are on 17th century. The 17th century witnessed an unprecedented increase in mathematical and scientific ideas throughout Europe. Galileo Galilei was able to observe Jupiter's moons with his homemade telescope based on toys imported from Holland. Tycho Brahe managed to collect a large amount of mathematical data describing the position of the planets in the space. Johannes Kepler studied the motion of the planets seriously and put forward Kepler's laws. He also made a mathematical formula of the laws of planetary motion. René Descartes developed analytic geometry by placing the orbits of the planets onto a graph of Cartesian coordinates. Issac Newton is perhaps best known for his contribution to physics. However, his service in mathematics should not be underestimated. His most famous work is the Philosopher Naturalis Principia Mathematica, or Mathematical Principle of Natural Philosophy, which was first published on July 5, 1687. In formulating his physical theories, Newton developed a method that we know today as calculus. Newton's calculus at that time used a different notation from modern calculus notation. Because of this, Newton is considered one of the founders of calculus. Another discoverer of calculus was Gottfried Wilhelm von Leibniz. He is considered one of the most important mathematicians in history. Separately from Newton, Leibniz developed differential and integral calculus. In his calculus, Leibniz introduced a notation that's still widely used today, like for derivatives and for integers. Leibniz also contributed to algebra and topology. He was the first to understand that the coefficient of a system of linear equations could be arranged in rows. We now call them matrices to find solutions to the system of equations. This method was later called Gaussian elimination. Leibniz is also known as a polymath and philosopher. Apart from astronomy and physics, the application of mathematics developed in new directions. Blaise Pascal and Pierre de Fermat teamed up to investigate probability theory and combinatoric rules in their discussion of gambling. On 18th century, the most influential mathematician of the 18th century was arguably Leonhard Egler. One of his contributions was the discovery of the study of graph theory with the 7 bridges of Königsberg for standardizing many modern mathematical terms and notation. For example, it represents the square root of -1 with the symbol I. He also popularized the symbol P to express the ratio between the circumference of a circle and its diameter. He made many contributions in topology, graph theory, calculus, combinatorics, and complex analysis. Another important mathematician of the 18th century was Joseph Louis Lagrange, who did pioneering work in number theory, algebra, differential calculus, and the calculus of variations. There was also Laplace, who had done important work on the foundations of celestial mechanics and statistics. Next, on the modern era, there are the 19th century. During the 19th century, mathematics became increasingly abstract. Carl Friedrich Gauss, known as the Prince of Mathematics, made revolutionary work on complex variable functions and the convergence of series. He was also the first to give satisfactory proof of the fundamental theorem of algebra and the quadratic reciprocity law. In this century, also developed two new geometric shapes besides Euclidean geometry. The Russian mathematician Nikolai Ivanovich Lobachevsky and his rival Janusz Bolyai, the Hungarian mathematician, separately defined and studied hyperbolic geometry, while one other form, namely elliptical geometry, was developed by the German mathematician Bernhard Riemann in the late 19th century. He also developed Riemannian geometry, which unifies and broadly generalizes the three types of geometry, and also defined the concept of the manifold, which generalizes the notion of curves and surface. The 19th century saw the beginnings of much abstract algebra. Hermann Grassmann in Germany provided the first version of vector space. William Rowan Hamilton in Ireland developed the non-commutative algebra. The British mathematician George Boole devised an algebra that soon evolved into Boolean algebra, which contains only the number 0 and 1. Boolean algebra became the starting point of mathematical logic and had an important role in computer science. Augustin Louis Cauchy, Bernhard Riemann, and Carl Weierstrass reformulated calculus in a more rigid way. In this century too, for the first time, the boundaries of mathematics were explored. Niels Henrik Abel, Norway, and Ferris-Tegolius in France proved that there is no general algebraic method for solving polynomial equations with more than 4 degrees. Abel-Ruffini theorem. On the other hand, the three-dimensional limitation in geometry was exceeded in the 19th century by considering the parameter space and hypercomplex number. Abel and Gelo's investigations into the solution of various polynomial equations laid the foundation for the development of group theory as well as fields related to abstract algebra. In the late 19th century, George Cantor built the first foundation of set theory, which allow us to understand precisely the ideas of infinity and has become a common language in almost all branches of mathematics. Cantor's set theory and mathematical logic, developed by Peano, Lex Brouwer, David Hilbert, Bertrand Russell, and Whitehead, are considered the basic foundation of mathematics. In the 19th century, several mathematical communities were established. These include the London Mathematical Society, the Société Mathématique de France, the Edinburgh Mathematical Society, the Crollo Matematico di Palermo, and the American Mathematical Society, and the Quaternary Society. And on the 20th century saw how mathematics became a mainstream profession. Every year, thousands of doctor, PhD degrees in mathematics are awarded, and there are many jobs available in education and industry. In 1900, David Hilbert, in a speech to the International Congress of Mathematicians, presented a list of 23 unsolved problems in mathematics. These problems, which cover many areas of mathematics, became the main focus of much of the mathematics on the 20th century. Currently, 10 have been solved, 7 have been partially solved, and 2 are still open, and 4 issues have yet to be declared solved or not. Several conjectures that stand out in history have been problems. Wolfgang Haken and Kenneth Apple used computers to prove the four-color theorem. Andrew Wills proved Fermat's-Less theorem or Fermat-Less theorem in 1995. In 1998, Thomas Callister Hollis proved the Kepler conjecture, mathematical collaboration of unprecedented size and scope. An example is the classification of finite simple groups, also called the enormous theorem, require 500 journal articles by about 100 authors and fill tens of thousands of pages. Differential geometry emerged when Einstein used it in general relativity. Entirely new fields of mathematics, such as mathematical logic, topology, and game theory, have changed the types of questions that can be answered by mathematical methods. All types of structures are abstracted by axioms and given names like metric space, topological space, etc. The concept of abstract structure leads to category theory. Grothendieck and Serre reconstructed algebraic geometry using Stephenson theory. Great progress was made in the qualitative study in dynamical systems started by Poincare. Measure theory was developed in the late 19th and early 20th centuries. Its application include Lebesgue integral Kolmogorov axiomatization of probabilism theory and ergodic theory. Knot theory is developed rapidly. Quantum mechanics broke the development of functional analysis or functional analysis. Other new fields include Lorentz quartz distribution theory, fixed point theory, singularity theory, and Rein-Thom's catastrophe theory, modal theory, and Mandelbrot fractals. The continuous development and improvement of computers allow industry to deal with large amounts of data to facilitate mass production, distribution, and communication. With this development, new fields of mathematics have also developed, including Alan Turing's computability theory, complexity theory, data analysis, and optimization. In this previous century, most mathematics focused on calculus and continuous function, but the development of computing and communication networks made the concept of discrete and combinatoric expansions even more important, including graph theory. The ability and speed of data processing on a computer enables the handling of mathematical problems that take too much time to do with pencil and paper, leading to fields such as numerical analysis and symbolic computing. Some of the most important methods and algorithms of the 20th century include the simplex algorithm, the fast Fourier transform, error-correcting codes, the Kalman filter from control theory, and the RSA algorithm of public key cryptography. One of the most interesting mathematicians in the 20th century was Srinivasa Iyengar Ramanujan, an Indian self-taught who has got and proved more than 3,000 theorems, including properties of very high composite number, partition function, and their asymptotics, as well as a Morse theta function. He also made major investigation into gamma function, modular forms, divergent series, hypergeometric series, and prime number theory. Then in the mid-20th century, in the United States, there was a mathematics teaching project led by Beberman, namely UICSM, or the University of Illinois Committee on School Mathematics. which emphasize understanding and discovery. Because this project is the forerunner of modern mathematics, Biberman, as the leader of the project, is called the father of modern mathematics. One of them created a modern mathematics movement, which is the continuation of the UEISCM project, namely the SMSG School Mathematics Study Group project led by Dr. Egler, the result of which were able to make a big difference not only in America but also for the teaching of mathematics around the world. Next, on 21st century, in 2000, the Clay Mathematical Institute announced 7 Millennium Prize problems, and in 2003, the Poincare conjecture was solved by Gregory Perelman, who refused to accept the award because of his critical attitude towards the establishment of mathematics. Many mathematics journals now have an online version such as the print version, and many journals are only published online. There are many observable trends in mathematics, the most notable of which are that the subject is getting bigger. Computers are getting more important and powerful. The application of mathematics to bioinformatics is growing rapidly, and the volume of data generated by science and industry, facilitated by computers, is explosively growing. I think that's all from me that I can explain on the topic of development of modern mathematics from transitional century to 21st century. Please forgive me if I had mistake in my explanation in this video. Hopefully this explanation video is useful for you. Don't forget to share this video with your friends and social media too. Thank you and good day.